Hey guys, samples and populations today. Okay, so checking out our first section here, we're looking at some vocab. So, samples and populations is our topic. First vocab words are about samples and populations. So, let's start with population, right? Population is the entire group of people or things. So, a lot of times we talk about people, but sometimes we talk about objects, books in a library, cars in a parking lot, whatever, stuff like that. So, for example, the population says the student population of the middle school is all the 6th, 7th, and 8th grade students, right? That's the whole population. When we look at a sample is a piece of the population, like a part of it. So, to continue that example, a sample could be the 7th grade, could be a sample, or the Lions team could be a sample, or my homeroom could be a sample, right? Anything that's a piece of the whole entire population, that's a sample. So that's the first thing to kind of distinguish, right? So, like, why do we care about samples and populations? Well, it says when gathering data, researchers need to determine whether to survey the entire population or just a sample of that population. If there's a lot of people or a lot of things, it might be really hard to sample everybody or everything, right? Like if you're trying to figure out the most popular type of car in a parking lot, or you know what people's favorite subject is at school or whatever, that might be difficult to talk to everybody in a school or look at every car in a parking lot. That might take a long time. So instead, we have to have a sample that we can use to kind of make a statement about the whole population. That's the point. So down here, real quick, these are pretty quick and easy. Identify the population and the sample. So remember, the population is everybody or everything. The sample is a part of that. So if we're looking at the students in a school versus the students in a math class, students in the school would be the population. The ones just in that math class would be the sample, right? Over here, the bears in a park with a GPS collar versus just the bears in the park. All the bears in the park is the population. The ones that have the special collar is the sample. And then down here, all the books in the library would be the population. 10 fiction books is a piece of that, so that's the sample. So that's real easy to kind of tell the difference. So when we think about samples, there's two different types of samples. We have unbiased samples, which are good, and we have biased samples, which are bad. So unbiased first. An unbiased sample has three things going for it. It's representative. Okay, representative means has lots of different types of people or groups of people or types of items or whatever you're talking about. It's random, so you don't know who you're talking to before you go out to do a sample, right? You're not like targeting individual people or things. And is large enough to provide accurate data. So you're not just talking to like two people or like three of your friends or whatever. So it's got to have all those things to be unbiased. A biased sample is bad. So when you see biased, right, like it starts with a B, you want to think bad. You don't want a biased sample. Biased sample is not representative because one or more parts are favored over others. Basically, doesn't have all three of these green highlighted things here. So unbiased is good, biased is bad. So down here, this got a little bit cut off, but this should say an unbiased sample needs all three parts. It has to be representative, random, and large for it to be unbiased, right? Okay, example 1. It says you want to estimate the number of students in a high school who ride the school bus. Which sample is unbiased? So remember, it has to be representative, random, and large. So 4 students in the hallway, I'm going to say probably not that one because that's only 4 students. That's not very large, right? That's just like a small group of people. All the students in the marching band, all the students in the band would be large, but it probably wouldn't really be representative of the school, right? You want to estimate the students in the high school. who ride the bus. If you're just talking to marching band people, that's not really a representative group of the whole high school. Those are just marching band people. So we're going to say probably not that one. 50 high school seniors at random. Well, it says it's random, which is good. 50 is like decently large enough if you think about the whole population of a high school, right? The problem here kind of is like you're just talking to seniors, which are 12th graders, right? So if you're a senior, you probably, you may not be riding the bus. You're less likely to ride the bus as a senior compared to any other grade in school, right? Because you can either maybe drive your own car, or you walk, or you get a ride with a friend, or whatever, right? If you're in elementary school or middle school, you're way more likely to ride a bus, or even like the beginning of high school where you still can't drive your own car yet. So that's probably not really a good group of people to ask. 100 students at random during lunch. This is the one we're going to go with because of these things. 100 students is large, right? That's a lot of people. You're randomly talking to them, so obviously it's random. And then during lunch is like a sneaky key factor here, because that means it's representative. Okay? Because when you think about this, it's not like we're just talking to the marching band people at band practice, or people who are at like a science club or something. It's people who go to lunch, which is everybody, right? Everybody goes to lunch. At the high school, there's a couple like at lunch, it's like everybody has to get to lunch. There's no skipping lunch, right? So there's all types of people at lunch. There's people who do sports, people who don't do sports, people who ride the bus, people who don't, people who do clubs, people who do things outside of school. It's a representative group of people. So that's really a great place to ask questions for surveys. That's why you see sometimes people at the mall or people at other events, right? Like doing surveys, because there's a mix of people there. Okay, let's keep going down. So first two questions here: identify the population in the sample. All the students in the school, or 30 of those students. Population would be all those students. Sample would be those 30 individual ones. 75 strawberries in the field, or all of them. All of them would be the population. The 75 would be the sample. Down here it says you want to know the number of students in your school who read some of the newspaper at least once a week. Okay, so who reads some of the paper at least once a week. You survey 50 random students that you meet in your team's hallway between classes. Okay, what is the population, right? Whatever you're trying to make a statement about, that's the population. So if it says you want to know the number of students in your school, right? We're trying to make a statement about this group of people. That's the population. So we're going to say students in the school. What is the sample? That would be those would be the people that we talk to. So the 50 random students, right? Is it biased or unbiased? Ask yourself that question now, right? Like, what do you think? Is it biased or unbiased? I would probably say this is going to be biased. It's close. You're talking to 50 people, which is decently large. It says you're talking to them randomly, but the kicker is you're talking to people in your team's hallway between classes. So if you think about our team, that means it's just people on our team, like just 7th grade students on the Lions team in our hallway, right? There's really no other people in our hallway typically. So it's typically just us, right? So if we're trying to know people in the school who read some of the newspaper, if we just talk to people in our hallway, that means we're probably not talking to any 6th graders. We're not talking to any 8th graders. We're not even really talking to any other 7th grade students on the other teams, right? It's just our team. So that's probably why that would be considered biased. Okay, down here it says which sample is better for making a prediction and explain. So this is the goal, right? You're trying to predict the number of residents in St. Lucie County who own a home. Okay. So we're thinking about the county, people who own a home. So basically it's like a would you rather sample, random sample of 100 residents in the county, or a random sample of 100 residents in this one city, which I'm assuming is in the county. If you're trying to make a statement about the county, you want to talk to people across the county. You don't want to just talk to people in one city, because maybe in that one city, like there's less people who own homes. Maybe there's more people who have apartments because they're just available in the city, right? But you want to talk to people across the county if you're trying to make a statement about people in the county, right? So we're going to say sample A. And for the explain, we just kind of talk through that. Number 8 here, it says predict the number of people at a beach who are wearing sunscreen, right? So which would you rather do here? Would you rather have a random sample of 50 people at the beach or a random sample of 5 people at the beach? When in doubt, you always want to go bigger, right? Because you're getting more data. So we're going to say sample A would be better, because if you just talk to 5 people, what if you happen to randomly pick 5 people who all really wear sunscreen all the time? Then you'd be like, well, everybody here wears sunscreen at the beach because these 5 people do. Or if you happen to just talk to 5 people who never wear sunscreen, you would assume like, well, I guess nobody at this beach wears sunscreen, right? So you want to talk to 50 people, because that way it's more likely that you get a whole bunch of different opinions, right? Which is good. That's what you want. Okay, so you're making conclusions about a population. That's what we're doing in that last one. So there's 2 different kinds of conclusions. You've got valid conclusions, which are good. Something being valid is like supported. It's good. And you have something that's invalid, an invalid conclusion. An invalid conclusion is the result of a biased sample. So that means your sample was either not random, not representative, or not large enough. A valid conclusion, you can make a valid conclusion when you have an unbiased sample. So when your sample is large, representative, and random, right? When it's all 3 of those things, you've got a valid conclusion. If there's something missing, you can't really make a conclusion about the population because something is wrong there. So if you made a conclusion, it would be considered invalid and not really applicable. Like you couldn't really make it. Down here, example 2, determining whether conclusions are valid. So here it says you want to know how the residents of your town feel about adding a new stop sign. So residents of your town, right? That's the population you're focused on. So how do the people in the town feel about adding a stop sign? Determine whether each conclusion is valid. Okay, so letter A. You survey 20 residents who live closest to the new sign. 15 support it, 5 do not support it. So you say, okay, 75% of the people in my town support this sign. So we have to say, is that valid or not? This one would be invalid, right? Because, first of all, 20 people, that's not very large, right? If you're thinking about a whole town and you're only talking to 20 people, not very large, right? You're talking to people who live closest to the new sign. So that's not really random either. You're just talking to the people who live right there. It's not really representative of the whole town, right? And if you think about like, why would a town put in a stop sign somewhere? It's probably because people are going too fast in an area, or they're not being safe, or maybe there's like a lot of accidents there or something. So if you talk to the people who live where people are like speeding by their house, they're probably going to say, yeah, I'd want people to slow down in front of my house and not like crash their cars and stuff, right? So they're probably going to be in favor of that. So we can't really just talk to those people if we want to know the position of like the people in our town. Okay, so then down here, it says you survey 100 residents at random. 40 support the sign, 60 do not. So you say, okay, 40% support the sign. This one would be valid because if we're trying to make a statement about the whole town, we want to talk to people across the town, like the residents at random across the town. So if we talk to the residents at random, then obviously that's random. 100 would be large, and it would be representative because it's not just the people who live right by the sign, it's people on the other side of town, people who live close to where the sign's going to be, all kinds of people. So that would be a good group of people to talk to. Okay, down here, last question. We can use samples and populations and all this to make predictions using proportions, which we've already focused on this year. So this says you ask 75 randomly chosen students how many movies they watch each week. There are 1,200 students in the school, so we have to predict the number of students who watch one movie a week. Okay, so I'll just read this part here because this is kind of good to focus on. The sample is representative of the population. So if you have an unbiased sample, it is representative of the whole population. It's selected at random and it's large enough to give us good data. So since it's unbiased, we can use it to make a prediction. So when you make a prediction using a sample, you set up a proportion. One ratio is going to be all about the sample, and then the other one's going to be all about the population. So if we surveyed 75 people, these are the results right here in this pie chart. This plus this plus this is 75, right? These are my survey results. So this information is going here in this first ratio. So let's say people who watch one movie a week, looks like that's 21 people. So we say 21 over the 75 people that were surveyed. We want to figure out how many students in the school watch one movie out of the number of students in the school, which was 1,200, right? So we'll set up something like this, and now we can cross multiply, right? We'll get 75n equals 25,200. We divide both sides by 75. Okay, and we'll get, 336 students, right? So if 21 out of 75 in my survey said they watch one movie a week, I can assume that same percentage of kids out of the whole school would watch one movie, and that would be 336 out of 1,200. Awesome. Hopefully that helped. See you guys later.